Solving radical equations. Now, the first type of equation you may see is given in this example. You need to get the radical expression by itself. So I need to get, in this case, everything that's under the radical, so the radical x by itself. In order to do that, I'm going to first add the 3 to the other side. So this is going to give me a 2 radical x equals 10. Then I need to divide everything by 2. This gives me that radical x equals 5. Now to get x completely by itself and out from underneath the radical, I'm going to square both sides, because right now I'm square rooting, so I'm going to square both sides. If it was a cubed root, then I'd cube both sides. If it was a fourth root, I'd raise both sides to the 4th power. So the radical and the square cancel out and leaves me with x, and 5 squared is 25. But this is not necessarily an answer until I check it. So I'm going to check that x equals 25 by plugging it in. So 2 and then the square root of 25 minus 3 equals 7. 2 times 5, we're only talking about the principal root here because the square root symbol is already drawn, minus 3 equals 7. 10 minus 3 equals 7. And just show me 7 equals 7. It works, so this is an answer. If it didn't work, then the answer would be extraneous, but it does, so we're good, and there's one solution. In the second example, both radical expressions are already isolated. There's nothing more that I can do, so I just need to go right into squaring both sides. This just completely cancels out the radical and the exponent and leaves me with 3x plus 4 equals 7x minus 8. I'm going to get the variable to one side, isolate the variable, so I'm left with 4 equals 4x minus 8. I'm going to get the variable by itself now. 12 equals 4x. When I divide by 4, I'm left with x equals 3. Again, this cannot be a solution until I check. So I'm going to check that x equals 3 by plugging it in to the original, so what they gave you. So 3 times 3 plus 4 is under the first radical, and 7 times 3 minus 8 is under the second radical. This is going to give me a 9 plus 4, which is 13, and a 21 minus 8, which is 13. I do not need to see the decimals from here. I don't even need to see, honestly, if the radicals can be simplified, which they can't in this case. All I need to see is that it works, so this is a solution. Now, in our final example, we need to get this radical expression by itself. And in order to do that, I'm going to add the x to the other side. So I get the square root of 6x plus 7 equals x plus 2. And I'm going to square both sides to get rid of the square root. It cancels on this side and leaves me with 6x plus 7. But on this side, this is the same thing as saying x plus 2 times x plus 2. It's a binomial times itself, so we need to use FOIL. So that'll give me x squared plus 4x plus 4, because the outer and the inner, 2x plus 2x, gives me 4x. I need to get it into standard form because it is a quadratic. So I'm going to subtract the 6x over and subtract the 7 over. So 0 equals x squared minus 2x minus 3. And then in order to solve, the easiest way would be to factor. You could obviously complete the square, but in this case, you're able to factor. It is factorable. So I break it into two binomials because the leading coefficient is 1. It's x squared, so it breaks apart into x and x. This means different signs, and the bigger number is going to be negative. So I need to figure out what two factors of negative 3 add up to negative 2 and have different signs. Well, the only factors of negative 3 would be 3 and 1. So if the 3 is negative, the bigger number is negative, 1 is positive. I break it apart and set each part equal to 0. So I get x equals negative 1, or x equals 3. But again, these are not solutions until I check them. So when I check x equals negative 1 in the original equation, That's the square root of 6 times negative 1 plus 7 minus negative 1 equals 2. Well, this is going to give us negative 6 plus 7, which is just 1. Minus negative 1 means plus 1 equals 2. The square root of 1 is 1, and 1 plus 1 does equal 2. So this is a solution. Now I need to check that 3 works. So when x equals 3, the square root of 6 times 3 plus 7 minus 3 equals 2. Well, 6 times 3 is 18. 18 plus 7 is going to give me 25, so it's the square root of 25. Minus 3 equals 2. I get 5 minus 3 equals 2, which means 2 equals 2. So this works, so this is also a solution. Now, if one of them did not work, so this is not in this example, but if one of them did not work, you label it as extraneous, and then you just circle the other answer. If it asks you what is the solution, you only give the solution that works. In this case, it would say what are the solutions, and there are 2 solutions, -1 and +3.